Hi everyone, we can solve two more questions in this video. The question is, here we have a set of instructions like move AL comma 25, move DL comma 22H, compare AL comma DL, JG label 1, INCDL, and in label 1 we have to perform DEC DL. So the question is, what is the content of DL register after the execution of these set of statements? Okay, so in order to solve this, we need to understand the meaning of different statements present in this set of code. Okay, first one indicate moving a decimal number 25 to register AL. Next, 22H, the hexadecimal representation 22, actually 34 in decimal. Its hexadecimal equivalent is this 22. Okay, so this 22 is moved into DL register. Then perform a comparison. So this CMP instruction actually works based on the principle we want to perform destination minus source. So here it is the destination. In destination we have AL register. In source position we have this DL. So perform a subtraction. And we want to check the value of or the magnitude and sign of the result. If the generated result after this subtraction is greater than 0 or less than 0 or equal to 0, we want to check the result. So, and based on the value, we want to set the flag registers, various flag registers. Okay. So, after this comparison, based on the result generated after this subtraction, that is actually taking place behind this CMP operation. Okay. So, after this, we have to make certain changes over the different flag values like sign, carry, etc. So based on the value, we need to perform this JG instruction. JG means jump if greater. What is the meaning of this jump if greater? If this destination is greater than the source value, the value present at destination, if it is greater than the source value, we want to perform this jump to a particular memory location which is labeled as label 1. Okay, that is the meaning of this JG, right? Jump if greater than means if the destination value is greater than the source value, right? Okay, so how can we identify if this destination value is greater than the source value? Based on the result of this comparison operation. If the result after this comparison is greater than 0, this indicate this destination value is greater than DL. Okay, if this satisfies, then we want to jump to a particular memory location which is labeled as label 1. In that particular location, we have this particular instruction to be executed. If the condition is not true or if it is violated, then no need to jump to this particular location. We can continue the instruction execution in a sequential order. That means after comparison, if this condition is violated, then we want to move to the next instruction execution. After this execution instruction, move to the next instruction and so and so. Okay, if this condition is true, we can skip this instruction, directly move to this label location and start the execution of this particular instruction, and after its instruction one after another. Okay, so this is the meaning of this set of code given. Okay, now we can consider the value. AL hold the value 25 in decimal, DL hold the value 22H, which is equivalent to 34 in decimal. Okay, so this comparison, consider this comparison. Actually, the source value is 34, destination value is 25, right? That means after this subtraction or this comparison actually generate a value less than 0. Because the DL value, the source value is greater than the destination value here. So after this comparison, this indicate a result, that is DL greater than AL or generate a result with value less than 0. So this condition get violated here. That means jump greater violated. So don't want to perform this jump operation. Directly move into the next instruction. Here we want to perform an increment operation. Increment INC means increment by 1. So perform the content of DL is added with a 1. So DL is modified to 23H. Initially DL with value what 22H, and after adding this 1, what will become this DL become 23H, right? So after that we want to execute this particular statement. Here it is a decrement statement. Decrement the same DL. So decrement value 1 from this DL content. So 23H minus 1, that is 22H itself. So after this execution, in this particular case, the result is 22H in this DL. Right? Suppose AL is with value 22H and DL is with value 25. That means AL with 34 and DL with 25. Then after this comparison, actually in behind it perform a subtraction destination minus source. It generate a result that is greater than 0. So this jump if greater satisfy. Jump if greater means if the destination is greater than the source or not. Here in this particular case, if AL with value 34 and DL with value 25, this jump if greater condition is satisfied, so directly jump into a location which is labeled by this label 1. So skip this particular instruction and directly move to this particular memory location that is labeled as this label 1 memory level. Okay, so here we want to perform this decrement operation only. So the current value of DL get decremented by 1. In that particular case, this 22 get subtracted from a value. This 22 is modified with a value, that is 22 minus 1. So after this decrement operation, the DL hold a value 21H. So this is the two cases. But based on the given information, given value, after the execution, DL hold a value that is 22H itself. Okay. Now we can consider one more example, one more problem. That is, here we have a data segment with different values stored in it. The first indicate a memory label MSG1 which store different bytes of memory and in which store values, a string, biggest. Okay, at the end we need to enter the ASCII equivalent of this dollar symbol in order to indicate the end of the string. After that, we want to store or we want to start the array declaration, and in that array we want to store these much decimal numbers. Each of these numbers are stored using 1 byte information. After storing these values in this array, we need to start next memory label, that is message 3, MSG3. Here also we want to store a string 5ELLO. Okay, so here we have double quote. This is a typing mistake, so consider this is a double quote. Inside we have 5ELLO and end with dollar symbol. Okay, so these are the content present inside this data segment. The question is, what will be the content of SI and BH register after the execution of the following instructions? And the instructions are move SI, offset MSG3, move BH, content of SI. Okay, so before starting the execution, we can just load this value into a particular data segment. Consider this is the data segment. The first location is labeled as MSG1, from where we can start the loading of this string biggest. So in the first location itself, we can store the hexadecimal representation for the ASCII value of capital B. So here we can store that value. In the next location, we can store the hexadecimal equivalent for the ASCII value of small letter I. And in next location, here store the corresponding value of G. Here store the corresponding value of G. Next E, S, T, and here store the dollar symbol, the hexadecimal representation for the ASCII value of dollar, which is actually 24H. Okay, so we have to store total 8 bytes. So from 0 to 7, we can store these values in this data segment. Right? After this 7th offset position, we can start this array allocation. Okay, so this array allocation start from this particular byte offset value 8. We can store 10, its hexadecimal equivalent here, 9, its hexadecimal equivalent here, 22, 34, 55 and 20. Total 6 bytes, and these 6 bytes are stored from A to D. So in this offset position or displacement position, inside this entire data segment, we can store the array elements. Total 6 bytes. Next, we can start the third label, that is MSG3, from where we can start storing the string YELLO. Okay, so total 6 bytes we need to store. So this position, we can store the hexadecimal equivalent of the ASCII value of 5. Here, the hexadecimal representation for the ASCII value of small e, L, L, O, and finally hexadecimal representation for the ASCII value of dollar symbol, which is actually 24H. So, and after allotting all these values or after loading all these values properly in this data segment, we need to execute these two instructions comes inside in our code segment. So, what are the instruction we want to execute? Move SI comma offset MSG3. That means the offset value of label MSG3 is loaded or pointed by the source index register after executing this instruction. What is the offset value of this particular memory label MSG3? From this allocation of our memory or data segment allocation, it is clear that the offset value of this particular label is E. Here we start the loading of the MSG3 memory label, from where we can store this string 5ELLO. We can start storing this string 5ELLO continuously one after another. So this is the location now the source index register pointing, or SI now hold the value, this offset value E. Right? So after that we want to perform this move operation, move BH comma content of SI. SI is pointing to this particular location. So content of SI is actually the hexadecimal equivalent of the ASCII value of digit 5. Okay, what is that? ASCII equivalent of 5 is actually 35. Hexadecimal equivalent of ASCII value of 5 is actually 35H. So this value is present in BH register and SI pointing to this particular offset location E. Okay. So this is the answer for this particular question. SI pointing to this particular offset position, which is marked as E inside this given segment, and BH hold the content of that particular location pointed by SI currently. SI pointing here and the content is the ASCII equivalent, hexadecimal representation for the ASCII equivalent of digit 5, which is actually 35H. So BH with value 35H and SI with value EH. Okay, thank you.